once on the practical, I really try to make sure that everything we did, there's at least a question about it. Some of them are really simple, some I cannot ask hard questions because what we did wasn't that complicated. So I'll give you a sense of that, especially things like the worms we looked at, the protozoans we looked at. That's just visually identifying them and being able to say, is it a eukaryote or is it a bacteria? Right? Those are the only two classifications I have for you to be able to do. It's pretty. It's a 50-50 here. So parts of a microscope, for sure. There's going to be a microscope out, and I'll point at two different things. So know the basic parts. Fine, coarse, focus, objective, ocular, stage, all that stuff. There's a diagram in every microbiology book. Let's deal with that. Protozoans. I'll have to look back at my notes and see which protozoans we looked at. But I would know the ones, there can be some of the ones in the book. Let's see, aseptic techniques. Hand washing, there really wasn't that much to, that is more just a general getting used to bacteria growing with bacteria in your skin kind of thing. So there really isn't much of that's when I don't typically have questions for. Aseptic techniques. Knowing the different hardware you use, slants, broths, loop, things like that. It's just sort of identifying it. You had to learn the word loop, right? So why not reward you for that? Bunsen burner. I don't know. You learn some new words, so why not ask me some questions and give me some quick learning. Parasitic worms. I think we looked at what?
Tapeworms.
Tapeworm, and we looked at one of pinworm. Okay, so know those in the classification. We're also today going to look at trichinella because it's got a really interesting biology to it, and I'm going to have you draw two things in the book on it. And hold on, don't write this down yet. I may modify that based on the time you have. I want you to look at trichinella because trichinella is cool. All right, simple stain and gram stain. That's where it starts to get into. There'll be a microscope out, and it'll be, simple stain. There's not much I can add to interpretation except for shape, right? The shapes, right? Cocci, bacilli, spirali. That's definitely something you can see when you do a simple stain. Gram stain. Gram stain is one that's a little more complicated. That one, it was a little, how it worked, it wasn't just adding a dye and washing it off, right? You add the crystal violet, you add the iodine, something happens, you wash out that complex out of gram-negative cells, but not gram-positive, right? So those steps, the 4 steps, basically how they work. I'm not speaking chemical reactions, but knowing the crystal violet iodine from the bigger complex, which cannot come out of gram-positive cells, worth some time going through because that it relates back to cell wall. Okay? And all of these, I would know what to know. I would know generally reagents. What did you use? Crystal violet, iodine, alcohol or acetone, and saffron, the counters. Okay. What's the trick, or how did it work? What's the trick? The trick in gram stain is forming something that won't. The crystal violet plus the iodine form something that won't come out of gram-positive cells, but will come out of gram-negative cells. That's the trick. Right? And cell structures. Cell structures, I'll say targeted, but what I'm not saying is when you do a gram stain, you're not actually seeing the thick versus the thin peptidoglycan. That's not what you're physically seeing. It's just what you see is the result of thick versus thin peptidoglycan. See what I mean there? See what I mean there? By targeted, I don't mean you're not ever directly looking at peptidoglycan unless you have an electron microscope. Right? You're looking at the results of there being thick versus thin peptidoglycan. These three questions sort of summarize what. So for all of these, I could change to reagents on the plates to what's in the plate. Right? Then what's the trick? Mannitol, salt, agar, high mannitol, that kind of stuff. Cell structures required, or we'll modify this. Okay, mannitol, salt, agar here. So mannitol, salt, agar. Remember the name sort of tells you what the important points are. On a plate, I would say, so this is for a microscope, for a staining. On a plate, I would say, or metabolism behind it. Okay, so far it's been pretty, it hasn't been really complex. An MSA plate, the mannitol, what metabolism happens on a mannitol salt agar plate that is the trick? What does it do that the verb used? Metabolize. You can be a little more sophisticated than metabolize. Ferment. Right, yeah, ferments. That's all. That's as deep as I can go on that, right? Ferments it, that makes acids, that lowers the pH, lower pH, you have a dye that is sensitive to the pH. Turns out. You should know, when I say reagents, know that it's mannitol, salt, and phenol red in that plate. And agar.
Do we need to know what makes it differential or selective?
Yes, differential versus selective too. Yeah. That's usually pretty straightforward. It's easy to get your mind around usually, so that's pretty good. So on mannitol salt agar plate, what does the salt do? Is it differential or selective?
Selective.
Okay. This gets into a little bit of a hairy bit here. What makes it differential? There's not one thing that makes it differential. Mannitol salt agar plate. It's what did you list here?
Mannitol.
But mannitol alone doesn't make it differential. You need not the salt,
Sodium chloride.
the phenol red, right?
Phenol red.
Now you need those two things together, because if you had a mannitol salt agar plate that you didn't add phenol red, it would acidify the media. It's just you would never know because you didn't have a dye in here. So you have to have those two together, right? So selective is often the selective agent. There's one thing. You go, these type won't grow because blah. But the differential, sometimes there's more than one thing you have to put in there just to see it. Okay.
So the differential is mannitol and phenol red.
Yeah, those two together make it a differential medium. Okay, I think did we even do photosynthetic microbes? All right, moving on. Fungi we'll look at today. What I would do is be able to just recognize. The questions there will be, it'll be a microscope with it on there, and you have to identify, is it, basically what is it, and there's some characteristic structures you're looking for. It's really obvious when I show you, you'll look and go, oh my gosh, this is easy. Okay. EMB. Let's look at this one. Let me go over to microbe library. Let's see. Go back. This is an associated American Society for Microbiology. And so this was the plate where. So here, this is the EMB plate, and this is where Y is. I could ask